pages on it. So if you look at the front, see, this is page 1, this is page 2, and then page 3 and 4. Yeah. Here we go. Problem number 1. Alright, so we've got a couple of conic sections. We have x squared plus y squared equals 4. What is that? A circle. And we have x plus y equals 2. What's that? A line. And our job is to find the point or points of intersection of a circle and a line. So how do we find where things intersect? Well, no calculator. How did you find where 2 lines intersected? Substitution or elimination. Anytime you want to know where 2 things intersect, you're going to use substitution or elimination. As much as I love the elimination, it's not going to work here because I can't eliminate x squareds and x's and y squareds and y's, right? So I'm going to have to do substitution. So what's your thought about that? Yeah, one of these you're going to substitute in for. So y equals 2 minus x, or you could do x equals 2 minus y. It's not going to make any difference. And then you'll take that and plug it in right here. So you'd have x squared plus 2 minus x squared equals 4. Now that's a FOIL. You'll be doing crazy stuff. FOIL it, FOIL it. I can FOIL that in my head because I'm old. If you can't FOIL that in your head, then you're going to want to FOIL it off to the side. So what do we got when we clean that up? 2x squared minus 4x equals 0. What do I do with that? Factor out of 2x, leaving me with x minus 2. What does that mean? It means x either equals 0 or x equals 2. Now, why did I write my answer that way? Because what am I looking for? Points. I'm looking for points. So now I know the x coordinates are 0 and 2. And if I plug in 0, I get 2. And if I plug in 2, I get 0. So these 2 curves intersect twice. Now, that never happened when you were intersecting lines. Because when lines intersect, the most places they can intersect is once. But if you have a circle and a line, does it make sense to you that you can have 2 points of intersection? Could you also have just 1 point of intersection? Could you also have no points of intersection? Yeah, and you don't know till you work it out and solve it, what situation you're going to have. This one has 2 points. All right, number 2, A. Write the equation of a parabola whose focus is 10, 3, and whose directrix is x equals 6. So I'm going to write the equation of the parabola given this focus and this directrix. All right, now first of all, it's been a while since we did problems like this. When we write the equation of a parabola, it looks like this. And sometimes it helps me to just think about, like, put numbers in it. So I've got equations that look like this. Right? That's what they look like. That's what a parabola looks like. So I've got this quantity squared. I don't know if it's x or y. I have to figure that out. And then I've got this really, really important 4p number here, right? It can be positive or negative. And then I've got the unsquared variable. All right, so what do we know about this parabola, given that directrix and that focus?
Y is right to the right.
We know it opens to the right, which automatically means that the y is being squared. What do we know about the vertex? Can we figure that out based on this information? Yeah, now this is at 6, and this is at 10, so that has to be the point 8, 3. 8 is right in the middle of 6 and 10. 8 is the midpoint of 6 and 10. 8 is the average of 6 and 10. Now be careful when you fill it in. The 8 goes with the x. The 3 goes with the y. Now I don't know what this is. I know it's positive, would you agree? And I know it's 4p. That number is 4p. What is p? This is p. What's p? 2. If p is 2, then 4p has to be 8. Now, I've got an ellipse with vertices at -2, 5 and -2, -3, and foci at -2, 1 plus √7 and -2, 1 minus √7. So my ellipse, looks like this. And I'm going to write the equation. Okay. So I know that the equation of an ellipse looks like this. So somehow from what I've been given, I have to fill out all those numbers there. Can I figure out the center from what I've been given? The center is going to be where x is -2, right? And y is where? 1. So x is -2 and y is 1. If you can't, eyeball that or figure it out from the foci or whatever, just find the midpoint of these 2 points. Midpoint is average. Just average the x's and average the y's. That will give you your center. Now, what about my denominators? Do I know anything about them?
Yeah.
I know the y has to be 16. Now, how do I know that the y has to be 16? This is my center. I went up 4 and down 4. Up and down means y. Up and down 4 means 16. What about that other denominator? We don't know. But we do know what? We do know that between the center and the focus, that distance is apparently √7. And how do I calculate that distance? What do I do to my equation? I subtract the denominators and take the square root. So the center to the focus is going to be, I'll call this n for a moment. The square root of 16 minus n. Which means n has to be 9. Okay. Now I'm going to do a hyperbola. So here's my setup for the hyperbola. And I know the vertices are 2, 6. And that's a vertex. And 2, -10. Right, now those are the vertices. So what does that tell me about my hyperbola opening? How does my hyperbola, it's opening up and down. Think about it. Those are vertices. It couldn't open any other way. What does that tell me? Just that. Y comes first. Now, somewhere in there is the center, would you agree? Somewhere between these 2 points? And not just somewhere, it's right in the middle.
-2.
Right, gang? Right in the middle? So, what's right in the middle?
2.
2, -2. Now, obviously, x is 2. Why -2? Because it's the average, the midpoint, the average of 6 and -10. Average, add them, divide by 2. So that means x is 2 and y is -2. Now take your time when you fill in those parentheses, get the letters or the numbers with the right letters. All right, anything else I know from this picture? I think so.
Get the Y.
I can get what's under here. How far up and down am I going? 8, so this has to be a 64. Agreed? Now I have no idea what goes under that, so I gotta see what else they told me. What else did they tell me? The asymptotes have a slope of 4/3. Now, I want you to think about building this box. Starting at the center, we know we counted up 8, right? Now I gotta go over, because here's gonna be my asymptote, right? So I know I counted up 8. I have to go over an amount that gives me this ratio. It's gotta be 6, which means under here must be 36. You gotta think about it backwards. You know when you have a hyperbola, you count, like if you had this one, you would count up 8 and over 6. That means the slope of the asymptote would be 8/6, which is the same as 4/3. Okay? And then finally, we have one more. Write the equation of a circle whose diameter Alright, so we got a circle, and the diameter has endpoints at -4, 7, and 6, 9. We're going to write the equation of a circle. Now, boys and girls, this is not a tricky problem. Remember the tricky one we did right before lunch? It was tricky because I gave you the endpoints of a radius. If I give you the endpoints of a diameter, there's no tricky. You know exactly what the center is, right? So it's the midpoint. It's the average of those. So -4 and 6, the average would be 1. And 7 and 9, the average would be 8. So your center is at 1, 8. Now what do we need? Only thing we need is the radius. So we can find it just doing the distance formula. I don't know why I always use this one. You could use this one too. It doesn't make any difference. So the radius is going to be the square root of 6 minus 1 squared and 9 minus 8 squared, which is the square root of 26. Now when you write your equation though, you don't put square root 26. It's x squared plus y squared equals r squared. So this is going to be a 26. Okay? So on test day, you're going to write 4 equations. A parabola, ellipse, circle, hyperbola. And I'm going to give you some information. You're going to have to create the equations. All right? Then you're going to have to classify the following. What does that mean? Tell what it is. Tell what it is. So here we go. What have we got? Take a look at that equation. Do not pay attention to the order it's in. Pay attention to what is x squared, what is y squared, and what is xy. Because remember, A goes with the x squared, B goes with the xy, and C goes with the y squared. So when you do your discriminant, B squared is not 5 squared. What's B squared? 2 squared. So 4, this is B. You might want to label it in the equation. That's B. This is A, and this is C. So B squared minus 4 times 2 times negative 5. Now again, go ahead and work that out if you want to. But it's not the number that matters. When we talk about the discriminant, what matters? Whether it's positive or negative. Is that going to be a positive number or a negative number? Positive. So this guy is a what is it? Its discriminant's positive, which means it's a what? Hyperbola. This one is a hyperbola. All right. Next equation. I'm not even going to write the rest of it down because it doesn't matter. When we're determining what we've got, the only thing that matters is A, B, and C, right? So B squared minus 4AC. Again, work it out if you want, but all I care about is that's going to be negative. That means that guy is an ellipse. Last one, number 3. B squared minus 4AC.
That's a circle.
That's not a circle. Circle's on part of this conversation.
Parabola.
It's a parabola. It's a parabola because the discriminant is exactly 0. And when the discriminant is 0, you have a parabola. Now, I just want to caution you because you know I'm tricky. And I want to mess you up every opportunity I have. Be careful. If that had just been plus 2y, then A would still be 2, B would be 4, but C would actually be 0. Make sure you're getting the x squared, the xy, and the y squared terms involved. Those are the only ones that get involved. All right, test is half finished. Let's see what the other half holds. Okay, so this is the part where I give you the equation and you fill in the blanks. All right, so the test will be structured this way, okay? So let's make sure everybody understands what's happening. See how those blanks there, look at problem 4A. See how the blanks are numbered? Those numbers correspond with the numbers at the top. So blank number 1, anything numbered 1 is going to be the eccentricity. Anything with a 2 is going to be the vertex or vertices, and so on. So not every problem has every number, because hyperbolas are the only thing that have asymptotes, right? So I'm not going to have that blank on any of the rest of them. All right, so here we go. Lots of points on this page for sure. All right, let's see if we can get this one done. We might make it, we might not. Let's see. What do we have to do? We have to complete the square. So we'll group our x's, taking out a 9. Group our y's very carefully, taking out a negative 16. And when I say carefully, please do it carefully. You're factoring out a negative 16. So that's going to make that a negative. Here we go. What goes here? 1, which is really a 9. What goes here? 9, which is really a negative 144. Is that 144? So beautifully read the problem, just for you. By the way, if you're taking your test and things don't work out, it means you've made a mistake. Or I've made a mistake. Because I'm going to try to have everything perfectly right, like it is here. Alright, so here we go. We're going to start filling in the blanks. We don't have to fill them in that order though, so let's just start doing what we do. Where's the center? Negative 1, 3 is my center. So in the blank numbered 6, you're going to put that point, negative 1, 3. That goes in blank number 6 because that's the center blank. Alright, let's do our vertices. So let's see, the 16 tells me to count sideways, 1, 2, 3, 4. And then, both ways. And the 9 tells me to count up and down 3. What did I do wrong? It's not in the mix. So I don't want to do that. What do I want to do? I need to make a box and draw in my asymptotes. Now I'm going to draw my curve. Okay, I'm going to draw my curve. Which way is it going? Left and right. So these 2 points right here are the vertices. So you're going to put those 2 points, negative 5, 5, or negative 5, 3, and 3, 3, in blank number 2. Those are the vertices for this hyperbola. There's 2 of them.
Mrs. Ford?
Yep.
May I please see Clark Arbogast to the front office?
Yep. Can you come when the bell rings or when period's over? She's gone. All right. Go ahead, Clark. Go ahead and go. All right. Now, let's get one more blank filled in. Let's get our foci done. All right. So here they are. Everybody good? They're back there like that. How far is it from the center to the focus? From the center to the focus, how far is it? Well, let's look at our problem. Oh, this is a nice one. From the center to the focus, it is 5. Square root of 16 plus 9. So you're going to start right here at the center, and you're gonna go forward 5. So where would you be? At 4, 3, and at negative 6, 3. So those two go in the blank 5. Now we're going to do eccentricity. That's blank number 1. What's the eccentricity for this hyperbola? 5 fourths. Whoever said that, I love you. 5 is the distance from the center to the focus. 4 is the distance from the center to the vertex. And that's how we build eccentricity. So we filled in every blank, I think, except the asymptotes, right? So we will do that next time. That's where we start. So someone needs to remember that's where we start. And we will finish this sheet next time, okay? Homework's due Monday. That means tomorrow we need to clear up any issues you have. Have a good day.